Hey everyone, let's talk about object-oriented programming, or OOP. Now I know it sounds super technical, maybe even a little scary, but what if I told you that you're already using it like all the time in Python, even if you have no idea? Well, in this explainer, we're going to pull back the curtain on OOP. We'll demystify it and show you why it's such an awesome tool for writing code that's cleaner, smarter, and way more intuitive. So let's start with a little riddle. Take a piece of text, the string hello, and a number, like the integer 5. On the surface, they seem totally different, right? But in the world of Python, what on earth could they possibly have in common? And the answer is, they're both objects. And that, right there, is the big secret. You've been working with objects from day one. See, OOP isn't some strange alien concept you have to learn from scratch. It's really about understanding a power you've been using all along and learning how to truly harness it. So let's start right there. Section 1, you already use objects. We're going to peel back the layers on the code you've been writing this whole time and reveal the object-oriented magic that's been hiding in plain sight. This idea is absolutely central to Python. When you write a string, you're not just making some text, you're creating an instance of the string class. That number 5, yep, it's an instance of the int class. It's kind of wild when you think about it. But pretty much everything in Python, even the functions you write, are actually objects under the hood. Think about it this way. You've probably used the little dot after a string a million times, right? Like mystring.upper. That's not just some random command. That .upper is a method. It's a behavior, something that string objects know how to do. The string class itself is what defines all these built-in abilities, and turning text into uppercase is just one of them. Okay, so you might be thinking, if we've already got these great built-in objects, why do I need to learn to make my own? That's a great question. So let's jump into section 2 and see why things can get really messy really fast when we try to model more complicated stuff. So let's picture a scenario. You're building a program to keep track of employee data. If you're just starting out, your first instinct is probably to grab a tool you already know and love, like a plain old list. So you might just whip something up like this. You make a list called McCoy, and you pop in his name, his job title, and the year he started. And you know what? At first glance, it works. All the data is there, in one place. But here's where the cracks start to show. What happens when your program gets bigger? When you come back to your code in a few weeks and see MCCI 1, are you going to remember that's his position? Probably not. And what if you add a new employee, but you forget one of the pieces of data? Suddenly, all your indexes are off, and your code just breaks. It's fragile, it's confusing, and honestly, it's a ticking time bomb. And now, this is the big aha moment. Just look at the difference here. On the left, you have this cryptic code where you have to remember what's at index 1. On the right, it's just clear. McCoy.position. You know exactly what that is. There's no guesswork. This is the beautiful clarity that thinking in objects gives you. So how do we get to that beautifully clean code on the right? Well, that brings us to section 3. It's time to introduce the absolute cornerstone of OOP, the class. The best way to think of a class is as a blueprint. It's not the actual thing itself, it's the plan for the thing. So an employee class isn't one specific person. Instead, it defines what it means to be an employee in our system. It says, okay, every single employee we create is going to have a name, a position, and a start year. It just lays out the rules. So if the class is the blueprint, then the object is the actual house you build from that blueprint. It's a real, tangible instance of that class. The class is the cookie cutter. The object is the actual cookie. McCoy is one object. Kirk is another object. Each one is a unique creation stamped out from that same employee blueprint. All right, that's enough theory. Theory is great, but let's get our hands dirty and see how this stuff actually works in code. So, section 4, bringing objects to life. We're going to build a super simple dog class, which is a classic example for a reason. It just makes sense. So here it is, our blueprint for a dog. It defines two main things. First, you see that special _initiate method? That's the constructor. It's the part that runs when we first create a dog and it sets up its data. In this case, a name and an age. Second, we define a behavior, or a method, called speak. This is an action that every single dog object we make will be able to do. Let's just walk through this real quick. Class dog kicks off our blueprint. That def underscore in it is our constructor. It runs automatically anytime a new dog is born. Now self is the magic word here. It just refers to the specific individual dog we're making. So when we say self.name equals name, we're saying for this particular dog, set its name to whatever we passed in. That's an attribute. And def speak, well, that's a method, an action it can take. Now, to actually use our blueprint, it's this easy. We just call the class name, dog, kind of like it's a function. We pass in the data it needs, a name, Miles, and an age, 4. And boom! Just like that, we've created a brand new dog object, a living instance of our class. And we've stored it in a variable called Miles. And once our Miles object exists, we can play with it. We use that dot notation to get its data, its attributes. So Miles.name gives us Miles. And we can tell it to perform its behavior by calling its method, Miles.speak, woof. See how clean that is? The dog's data and its actions are all bundled up together in one neat little package. So why is this such a big deal? Why is this a fundamental shift in how you code? Let's get to our final section and really nail down why thinking in objects changes pretty much everything. Well, first off, it's all about reusability. You write that dog blueprint just one time, and then you can use it to create one dog or 1,000 dogs or 1,000,000 dogs. Each one will be a unique object with its own name and age, but you never have to rewrite the logic. That's incredibly powerful. So when you boil it all down, it comes to this. OOP lets you organize your code by bundling data and behavior together. It lets you reuse that code by stamping out as many objects as you need from a single blueprint. And because of those two things, it lets you scale. You can build huge, complex programs that are actually manageable, readable, and way easier to maintain. And believe me, we have just scratched the surface here. The rabbit hole goes way deeper. There are other amazing concepts like inheritance, which lets one class, well, inherit all the abilities of another one. You could have a general animal class, and then have dog and cat classes built on top of it. It's an amazing way to stop repeating yourself and build really elegant code. You know, at the end of the day, OOP is more than just a programming technique. It's a whole new way of looking at problems. It's how nearly all modern software is built. A character in a video game, that's an object. Your profile on a social media site, that's an object. It's all about modeling the real world in your code. We just modeled a simple doc, but you could model a car, a customer, a product, a bank account, anything. So I'll just leave you with this question. What part of your world are you going to model next? And that's our look at object-oriented programming. I really hope this helped make things a bit clearer for you. From all of us here at NTN Studios, thanks for tuning in.